Z. Okay, so here's your F here, that's ABS, abs, absolute. Your domain is now just the integers, Z, capital Z, and your range, the same, also Z. Okay, so abs, colon, Z, arrow, Z. That is, you know, for this example, abs, for this general case, where you function F maps the domain D into the range R. Maps elements of this set into elements of that set. Maps an element of this set into an element of that set. Alright? Okay, what else? Alright, let's apply this kind of terminology now to our two-input function, which was add, So F now will be ADD. Now what's the domain? It's the set of possible inputs. Well, we have two inputs. So let's say the inputs are elements of a Cartesian product, okay? A comma B, where A is one input number and B is the second input number, okay? A and B. So let's say they're integers. You're setting up a model, and you can define what numbers are. A number's going to be integers, they're going to be real numbers, they're going to be complex numbers, whatever. Okay, so we have to specify the problem. So let's assume, keep things simple. Let's assume that the input numbers are just integers. Okay, so we've got two of them coming in. So let's say let's model the input as an ordered pair. So A comma B. So those ordered pairs, by definition, they are elements of a Cartesian product, right? A cross big B. So let's make our domain then. Now, since A and B are integers, so the ordered pair, they are elements of Z cross Z, because big set A is a set of integers, and big set and set big B, capital B, is also a set of integers. So with these ordered pairs coming in, they are elements of a Cartesian product of Z cross Z. Right? So the domain then, your inputs, the set of inputs, is therefore this set, the Cartesian product Z cross Z. Okay? And the output, they'll be non-negative integers. That's the output. Because it's hold on, sorry, talking add. Oh, well, that's then. In this case, the output can be positive, negative, or zero. Okay, and just adding integers. So your output is just the elements coming out belong to the set Z integers, and in fact, all of the integers could be used as output. Yeah. Okay. So your f of d of r takes this form. Your f will be like ADD. That's the symbol for this function. The add function. This one. Your domain will be the Cartesian product, Z cross Z, right? Because your two inputs, A and B, little b, assumed to be integers. Okay. So big A, capital A, is Z, and capital B, big B, is again Z. Right? So your domain is the cross product Z cross Z, and the range is just Z. So you rewrite this as this. Okay. All right. So I'll swap over the chair. Whoop. Okay, Now, in the case of abs, absolute, the output, would we do it? You can't see it. Yeah. In the case of abs, we wrote this as abs colon z arrow z. Now the output values, they were non-negative integers, right? Because it's absolute. So in other words, the negative integers of big Z never got used by abs, this function. Okay, so this note in the second square of this session is it's a remark, if you like. It's saying that it's possible in a function that some of your range, some of the elements in your range, that set, a range is a set, a domain is a set, some of the elements in that range set never get used by the function. That's a possibility. And that's true for abs, but it was not true for add, because it's possible you can have any kind of integer as an output of this, right? When you're adding, because you can add negative numbers, give you a negative sum. So in the case of add, that when the function is add, it's possible that all members of your Z, your range, get used. In other words, all possible integers could or put it this way, any member of Z, any integer, that could be the result of the output of this function add. I hope that's clear. Okay. For example, so with the function abs, you'll never get an output from this function that's equal to -1, right? Because it's negative. But -1 belongs to Z, right? So there are some elements, for some functions, there are elements, like a subset of your range, that never get used, right? That's a possibility. Okay. Now, here's another term here, onto. A mapping is said to be onto. What does that mean? That means when every element of the range gets used, okay? Gets mapped to. So you don't have any. What's the word? You don't have any unattached. You don't have any members of your range that are not mapped to, that are not used. Right? When you have that kind of mapping, so every element of your range gets mapped to by something in your domain. Think of terms of arrows, like no, don't worry about it. Okay. Okay. So if every element in range is used, it gets mapped to that mapping. That function, that f, is said to be an onto mapping, right? So the function maps onto the range. Okay. All right. Now I'll change direction a little bit. You can describe a function, and we'll do two ways here. You can give a description of what a function is doing. How does the function determine its output? Give